So welcome you all to the training session of 7QC tools. Today is the second day of this session, and in today's session, after the clause of confidentiality, we will quickly go through what we have learned yesterday. Then we will start with the tool number 3, that is control chart, and then we will start tool number 4, that is scatter plot. So today we have to complete 2 tools. So clause of confidentiality, as we are telling you at the start of every session, the training content is of proprietary nature. Do not share the training content, the screenshots, the recordings on any of the public platform without our consent. Share the knowledge, do not share the contents directly. So tool number 1, check sheet, that we have seen yesterday. Check sheet is a very simple tool, yet very important tool, and we have seen कि इसको कैसे बनाया जाता है. चेक शीट को बनाने के लिए आपको लोगों को इन्वॉल्व करना है, उनसे इनपुट्स भी लेने हैं, ट्रायल चेक शीट आपको लॉन्च करनी है, एंड देन you have to make the final check sheet and start collecting the data. The purpose is to collect the data so that you can, yes Birendra, I will, है ना. So the purpose is कि आप डेटा कलेक्ट करो और उसको एनालाइज करो. तो चेक शीट में हमको क्या करना है, you have to collect the data. Data collection is done through the check sheet. We have seen certain examples of check sheet. कल हमने कुछ examples भी देखे थे check sheet के. Vaishnavi, please keep mute yourself. There is a background noise from your side. Mute yourself.
Okay, sir. Okay, sir. Sorry for this.
No issue. Then we have seen various examples of the check sheet also. ये जो हमारी व्हीकल जाती है सर्विसिंग के लिए, वन ऑफ द काइंड ऑफ अ चेक शीट दैट वी हैव सीन. And then we have made a check sheet not for collecting the data. Yesterday we have made a check sheet for visitors which are coming to your factory. So yesterday we had taken an example and prepared a check sheet for mentioning the details of the person visiting to your factory. Then tool number 2, that is cause and effect diagram, or you can say Ishikawa diagram or fishbone diagram also. This is basically used to find out various causes, अलग अलग causes जिससे कि result होता है effect or problem. So various causes which are resulting into a problem. To find out the probable causes, we are using this cause and effect diagram. We have seen how to prepare that. Important जो चीज है, that is a brainstorming. Brainstorming में you have to involve the people, take the inputs from them. उनसे हमको inputs लेने हैं और note down करने हैं probable causes, and then उसको various categories में, like man, machine, method, material, mother nature and measurement की कैटेगरी में हमको उसको डिवाइड करना. वी हैव टू डिवाइड दैट प्रोबेबल कॉजेस इनटू वेरियस कैटेगरीज. वी हैव सीन एन एग्जांपल ऑफ एन एक्सीडेंट हैपेंड एट द ट्रैफिक सिग्नल एंड वी हैड डन द ब्रेनस्टॉर्मिंग सेशन. सभी जो पार्टिसिपेंट थे हमारे, उन्होंने उसमें पार्टिसिपेट किया, एंड ऑलमोस्ट 19 सजेशन, 19 प्रोबेबल, नॉट सजेशन, 19 प्रोबेबल कॉजेस हमने लिस्ट डाउन किए थे कल. राइट फ्रॉम सिग्नल जंपिंग, सिग्नल प्रॉब्लम, एक्सेलरेटर प्रॉब्लम, हेल्थ प्रॉब्लम, टॉकिंग ऑन द टेलीफोन, ड्रंक एंड ड्राइविंग, ओके, मैकेनिकल इशू, विजिबिलिटी इशू, रोड कंडीशन, ऑल दिस कैन बी द प्रोबेबल कॉजेस. और फिर हमने देखा था कि जो प्रोबेबल कॉजेस है उनको वेरीफाई करना पड़ता है कि व्हाट चेक्स एंड बैलेंसेस वी हैव केप्ट देयर, व्हाट काइंड ऑफ चेक्स एंड बैलेंसेस हमने वहां पर लगा के रखे हैं, ताकि उस प्रोबेबल कॉजेस के ऑकरेंस के टाइम पर द प्रॉब्लम शुड नॉट हैपन. नाउ द टूल नंबर 3, that is control chart. Very important tool. very critical tool, widely used in the industries. One of the best tool I can say, है ना, ये जो कंट्रोल चार्ट है ये सबसे बेहतरीन टूल है आपके प्रोसेस के वेरिएशन को मॉनिटर करने के लिए, टू मॉनिटर द प्रोसेस वेरिएशन, टू फाइंड आउट द कॉजेस, स्पेशल कॉजेस और कॉमन कॉजेस ऑफ वेरिएशन, और उसके ऊपर एक्शन लिया जाए ताकि प्रोसेस में वेरिएशन कम से कम हो। जितना कम वेरिएशन होगा प्रोसेस में उतनी आपकी प्रोसेस कंट्रोल में रहेगी। The chances of process going out will be lesser. The chances of accident will be lesser. So what is this control chart? The tool number 3 control chart. It is also known as Shewhart chart. Why Shewhart chart? Because Mr. Walter A. Shewhart has invented that one, you can say, or started utilizing that one. The concept has been given by the Dr. Walter A. Shewhart. It is like if you see at the structure, वो आपको एक लाइन ग्राफ जैसा दिखता है ना, it just looks like a line graph, and it is basically used to monitor the product or process parameters over a period of time. So it's a live tool. It is not like you will collect the data today and after 3-4 days you are going to plot. No, it is not a postmortem thing. Okay, it is a live data. आप लाइव कलेक्ट करते हो, उसको प्लॉट करते हो ऑन द ग्राफ, एंड यू मॉनिटर द ट्रेंड ऑफ दैट पर्टिकुलर डेटा, एंड बेस्ड ऑन द ट्रेंड यू टेक द एक्शंस। जो ट्रेंड होता है उसके बेस पे आप एक्शंस लेते हो। नाउ कंट्रोल चार्ट, हाउ, व्हाट आर द वेरियस कंपोनेंट्स ऑफ द कंट्रोल चार्ट? A control chart will have an average line, a LCL and UCL, the data, and it will have the event log also. We will go in detail in the next slides. Control chart will let you know whether there is a special cause of variation present in the process or not. There are two kinds of variations. One is called special cause, another is called the common cause. Okay, the common causes are inherent in the nature. Now tell me, can you wake up? What time you woke up? Anybody can tell? Virendra, what time you woke up in the morning? Yes, Virendra, what time you woke up in the morning? कितने बजे आप उठे आज?
6 o'clock, sir.
हाँ, now is it 6 o'clock और 6:01 पे, 6:02 पे, 6:04 पे?
हाँ सर, समथिंग।
क्या आप एग्जैक्टली सेम टाइम पे रोज उठ सकते हो क्या? Is it possible that you woke up same time, exactly same time every day? Is it possible?
No, sir.
हाँ. So the variation what you have कि 6:01 पे, 6:02 पर, sometime 5:55 or 5:59, this is basically caused by a inherent nature of the process. Our waking up process is like that. It may vary little bit. अगर even if you woke up at 1 minute past 6 o'clock, there might be a difference of certain seconds. So this particular variation which is inherent in the process is called common causes of variation. It will always be there. A simple process like waking up will have the variation. So industrial processes, complex processes जो होती है उसमें भी variation होगा ही होगा. But one day you woke up at 7 o'clock. Is it normal? If you woke up at 7 o'clock, is it normal? क्या ये नॉर्मल थिंग है? आप इंस्टेड ऑफ 6 o'clock you woke up at 7 o'clock. Is it a normal thing? Is it a normal variation?
No, sir.
नहीं, है ना. तो क्या कारण हो सकते हैं? एवरीबडी कैन आंसर. ओके, what can be the reason for waking up at 7 o'clock instead of 6 o'clock? There can be certain reason. Can you attribute certain reason towards that?
Sir, late sleeping.
Late sleeping. Okay, other people can also, Rahul, Upender, Vaishnavi, you can also say what can be a cause for this waking up late.
He may be
Yes,
sick.
Yeah, one by one.
Sir,
Yes.
body pain के कारण भी.
हाँ, तो हेल्थ इशू के कारण हो सकता है. ओके, देन yes, Vaishnavi, you want to say something?
Hello.
Yes.
Yes, sir. I am also same answer. Late sleeping or otherwise health related problem.
Okay. Maybe holiday also. It can be a holiday also. So basically, for this particular variation, you can attribute, you can say why it has happened. So you can assign this is called assignable causes of variation. You can assign some problem. It's a special cause. Okay, certain time it is not like this much variation is only a special cause. Sometime if you continue to wake up late, like 6, 1, then 2, 3, 3 minute past 4, 5, 6, 6 past 6 minute, 7. So if that trend is also increasing continuously or decreasing continuously, then also there can be a special cause. That I will let you know afterwards during this training session, today's topic. Okay, so the main thing you should understand from the control chart is whether there are any special causes are present or not, or when there is a special cause present in the process, your process becomes unpredictable. आपकी जो process होती है ना, वो unpredictable रहती है. You cannot predict that one. It happens suddenly. Okay, it is not a pre-planned thing. So आपकी process में special causes नहीं होना चाहिए. You should not have special causes in the process. Only the variation should be because of a common causes of variation. कंट्रोल चार्ट्स अ लिटिल बिट डिफिकल्ट टॉपिक आई कैन से. थोड़ा सा डिफिकल्ट है. इसके अंदर फॉर्मूलेज है, स्टैटिस्टिक्स इन्वॉल्व है, फंडामेंटल्स थोड़े से डिफिकल्ट है इसमें. नाउ एज आई टोल्ड यू व्हाट आर द वेरियस कंपोनेंट्स ऑफ द कंट्रोल चार्ट. कंट्रोल चार्ट के अलग अलग कंपोनेंट. यूसीएल मीन्स व्हाट? अपर कंट्रोल लिमिट. यूसीएल इज अपर कंट्रोल लिमिट. Then there is a LCL, lower control limit. Then there is a mean, that is average. Then there is a data points. These are the data points. So the components of the control chart are data point, mean value of the data, that is historical mean basically, and the LCL and UCL. Apart from that, there will be a event log. So event log is basically if any variation occurs or any point certain things, some action has been done, you note down the detail of that particular event. है ना, आप नोट डाउन करते हो इस जगह पे क्या किया गया था, कुछ एडजस्टमेंट किया गया था क्या सेटिंग्स में, या कुछ प्रोसेस का वेरिएशन हो गया था क्या. सो दैट इवेंट लॉग, लाइक when you woke up late that particular day, you note down ki you slept late. What was the reason for that one, for that particular variation? Or even normal things also, if you do certain things in the normal variation also, अगर आप कुछ एक्शन लेते हो तो भी आप उसको वहां पर मेंशन करोगे. सो इट कैन बी मेंशन ऑन द ग्राफ इटसेल्फ, ग्राफ पे भी लिख सकते हो आप, or it can be written on a separate sheet attached to the control chart. Now this control chart जो है ना, it's a live tool. आपको ये शॉप फ्लोर पे डिस्प्ले होना चाहिए ऑन अ पीस ऑफ ग्राफ, और इफ देर इज अ डिजिटल डिस्प्ले, अगर आपके शॉप फ्लोर पे टीवी पे डिस्प्ले कराना है तो यू कैन डिजिटली डिस्प्ले दिस ऑल्सो, कि आप कंप्यूटर में डाटा एंट्री करो, बट पॉइंट ऑफ यूज जहां से इसका डेटा आ रहा है, द पॉइंट ऑफ यूज मीन्स from where you are collecting the data, it should be displayed near to that. It is a visual management thing, है ना, you have to manage the things visually. The Japanese factories focuses on visual management. जो जापानीज फैक्ट्रीज होती है वो विजुअल मैनेजमेंट के ऊपर फोकस करती है, क्योंकि जहां पर काम हो रहा है वहां पे अगर एक्शन लेंगे तो वो इफेक्टिव होगा, क्विक होगा. Otherwise, what will happen? You are maintaining data somewhere, your production or the actual thing is going on somewhere. There is no communication between the user and the person who is noting down. So it is not going to help you. It is just a collection of the data, waste of the efforts. Now there are various types of control charts. Okay. Now control chart, you understand कि what is the control chart? Control charts are used to plot the data. आपका जो डेटा होता है प्रोसेस का, उसको प्लॉट करने के लिए कंट्रोल चार्ट यूज किया जाता है. एंड यू विल मॉनिटर द ट्रेंड. जो उसका ट्रेंड है, यू विल मॉनिटर दैट वन एंड यू विल टेक एक्शन बेस्ड ऑन द बिहेवियर ऑफ द ट्रेंड. नाउ depending on the type of data being collected, there are various kind of control charts. The variable type of data, there are X chart, that is called charts for individuals, IMR chart or XMR chart, that is individual moving range chart, then X bar R chart, and then averages range chart. X bar S chart, that is averages standard deviation chart. So these are the various charts. There are many more also. Yes, Birendra, we will go to the Excel sheet and we will tell you that how to calculate the control limits. Specification limit is different, control limit is different. So when we go to the Excel sheet, we will let you know. हम आपको बताएंगे कि कंट्रोल चार्ट की कंट्रोल लिमिट्स कैसे कैलकुलेट की जाती है ना. I will show you with an example. Then attribute type of data में आता है NP chart, P chart, C chart and U chart. Now this SPC topic, or you can say this control chart topic, is huge. It is not able to cover it in the 2 hours. Okay, normally 1 hour we are giving for each and every tool. 8 tools are there. So it is very difficult to control everything about the control charts, about the process, about the statistical process control in the 1 hour. तो हम आपको यहाँ पे ब्रीफ में बताएंगे कंट्रोल चार्ट के बारे में. एक टिपिकल कंट्रोल चार्ट वी विल शो यू हाउ टू प्रिपेयर. बट इफ यू वांट टू लर्न मोर अबाउट द कंट्रोल चार्ट, अबाउट द प्रोसेस कैपेबिलिटी, CPK, PPK, all these things are covered in our separate training program of statistical process control, that is SPC. And that training program is for almost 9 hours. So 9 hours there will be a discussion on various control chart, how to prepare each and every control chart, what is data, what is median, what is standard deviation, what is CP, CPK, PP, PPK, what is the sigma. All these things are taught in that particular training program of 9 hours. So in this training program today, we are just discussing the brief things. Now, how you are going to prepare a control chart? So as a part of training program, we have to tell you how you are going to prepare a control chart. So the first thing is to identify the process to be monitored. So there might be a, for example, tire curing process. So you want to monitor the time or temperature required for the curing. You want to monitor the curing temperature, for example. Okay, or you want to monitor the certain temperature which is you are using for the explosive manufacturing, or you want to monitor the furnace temperature you are utilizing for the patenting of the wires. So these are the various parameters you want to monitor. So first thing, identify the process to be monitored and then determine the parameters to be monitored. Whether you want to monitor the heat treatment process, whether you want to monitor the punching process, whether you want to monitor the patenting process, what kind of process you want to monitor, whether you want to mixing process, curing process, and then what parameter, whether you want to monitor pressure, temperature, time, what you want to monitor. So that you need to determine. आपको decide करना है कौन सी process और कौन सा parameter. And then you need to determine the measurement method for collecting the data. How you are going to collect the data. Now you tell me what kind of tool you are going to use to collect the data. कौन सा tool use करोगे आप data collection के लिए?
Sir, check sheet.
Good. So you are going to use check sheet to collect the data. The measurement method is basically, yes, Upendra, good. So measurement method that you are going to use is basically whether you are taking the data from the thermocouple, whether it is from the digital display, whether you are going to take it using the vernier, and all these things. That is a measurement method basically. And that data you will note down on the check sheet, a quality tool. Then determine how to collect the data. What is the sample size? What is the frequency of sampling? It is not necessary कि आप continuous data लेते रहो. You may say like if there is a bulk process, you are manufacturing 1,000 parts. So you may not be checking the 1,000 parts. You may decide that after every 100 parts, you will check 5 parts. Then again next 100, you will check 5 parts. So that is basically a subgroup of 5. You are saying these 5 samples are representing all the 100 samples. Okay. So this is basically you are saying frequency of sampling. What is the sample size? Frequency of sampling. Then you start collecting the data. You note it down on the check sheet. You prepare a check sheet. You collect the data. Now, the data what you have collected, because now you have to calculate the LCL, UCL and the average. You need to make the trial control chart first. For that you need to collect the data and afterwards it's a live plotting. Okay, एक बार आपको average, LCL और UCL कैलकुलेट करने के लिए डेटा कलेक्ट करना पड़ेगा. उसके बाद it will be plotted live based on that average and the LCL and UCL. फिर आपको प्रोसेस का एवरेज आपने कैलकुलेट किया, आपने LCL and UCL you calculated using the appropriate formula for that particular control chart. Because you know the various control charts have various formulas. हर एक कंट्रोल चार्ट का अपना एक अलग फॉर्मूला है टू कैलकुलेट द LCL and UCL. After this, you are going to plot the trial control chart. What you are going to do? You are going to plot a trial control chart or initial chart. Then you will determine whether a process is in a state of statistical control or not. You will determine whether your process is in a state of statistical control. Now, statistical control में तब होती है process when there is no special cause. अगर आपकी प्रोसेस में कोई स्पेशल कॉज ऑफ वेरिएशन नहीं है तो आपकी प्रोसेस स्टैटिस्टिकल कंट्रोल में होती है. आप आइडेंटिफाई करोगे कोई स्पेशल कॉज तो नहीं है उसमें वेरिएशन. जब आप प्लॉट करोगे कंट्रोल चार्ट, यू विल कम टू नो देयर आर वेरियस ट्रेंड्स, जिससे कि आप पता कर सकते हो कि देयर इज अ प्रेजेंस ऑफ स्पेशल कॉज. ओके, दैट आल्सो आई विल टेल यू, डोंट वरी. Now, if there is any special cause present, you will remove that special cause, again collect the data, again you recalculate the mean and control limits if necessary. Now, once you have the upper control limit, lower control limit, and your mean, you will continue to plot your data, the live data that you are collecting from your process or from your products. You will continue, you will continue to collect the data. And you will monitor the trends, how your data is moving, you will monitor continuously. Okay, and you will take the action. It is just like you drive a vehicle, you drive like this. Okay, you cannot be at the same spot every time. You cannot draw you straight lining. Okay, there will be a slightly variation. Now, if you are driving like this and suddenly you go on this side, what you will do? Normally, what you do? Don't you take action and come back to the original position? Try to come back to the normal position. You will make, आप क्या करोगे? नॉर्मल पॉइंट पे आने की कोशिश करोगे. Secondly, for example, you are driving like this and suddenly you start driving like this. Now it is, you can take it as a upper control limit and lower control limit here. You are not gone outside it. Okay, still something is happening. That's why you are driving like this. कुछ तो हो रहा है जिससे कि आपकी ड्राइविंग इस साइड में जा रही है. तो आप क्या करोगे? यू विल करेक्ट योर पाथ. सो ये जो स्पेशल कॉज होता है ना, इट इज नॉट नेसेसरी कि आप कंट्रोल लिमिट के बाहर जाओ तभी स्पेशल कॉज है. ओके, स्पेशल कॉज कैन बी विद इन कंट्रोल लिमिट ऑल्सो. अ स्पेशल कॉज कैन हैपन. कुछ प्रॉब्लम होता है जिसके कारण स्पेशल कॉज वहां पर रहता है. नाउ यू नीड टू आइडेंटिफाई, यू नीड टू टेक द एक्शन on that special cause. Now I will give the example of a driving itself. You just imagine this is the a road. Basically it is a lower control limit and it is a upper control limit. Okay, now there are three persons who are driving. One person is driving here, another person is driving here at the center, same variation, driving here. Now tell me the chances of who. This is A, this is B, and this is C. Okay, the chances of which person is more to go out of the control limit, who can go out of control if something happens, if some problem happens, who can go out of the control limit fast? Person A, person B or person C? The question is for all, है ना. कौन ऐसा है जो आउट चला जाएगा? ये ड्राइवर है A, ड्राइवर B, ड्राइवर C, एंड दिस इज योर कंट्रोल लिमिट्स. कौन सा पर्सन जो आउट चला जाएगा? इसमें कुछ प्रॉब्लम होता है और द चांसेस कि ये कभी ना कभी बाहर चला जाएगा. किसका ज्यादा रहेगा? A एंड C. यस, गुड, है ना. सो द चांसेस ऑफ पर्सन A एंड C इज मोर. ठीक है, कि कभी भी ये बाहर जा सकते हैं, कुछ भी अगर प्रॉब्लम हुआ या फिर नॉर्मल, बिकॉज वेरिएशन टेंस, है ना. सो सी पर्सन चांसेस इज मोर. बी पर्सन जो सेंटर में है और कम वेरिएशन है, उसके चांसेस कम रहेंगे. नंबर 2, अगर ये बी पर्सन आगे जाके ऐसी गाड़ी चला रहा है, कभी यहां कभी यहां, अब बी का भी चांस रहेगा कि नहीं बाहर जाने का? आप सेंटर में हो बट आप देखो कभी इधर जा रहा है कभी इधर. सो इट इज अनप्रेडिक्टेबल, समटाइम हियर समटाइम देयर. सो द चांसेस इज मोर तो आपको क्या करना है, आपकी प्रोसेस वेरिएशन कम रहना चाहिए, इट इज क्लोज, द प्रोसेस शुड रन वेरी क्लोजली एंड प्रोसेस शुड रन इन द सेंटर। ओके, तभी आपके प्रोसेस की जो कैपेबिलिटी होती है ना सीपीके, we are not going into detail of the CPK basically, but just as we are on the topic, I am telling you the capability of the process will depend on the where your process is running, location and with what variation। वो प्रोसेस कहाँ पे चल रही है और कितने वेरिएशन के साथ चल रही है। अगर आपकी प्रोसेस सेंटर में चलती है, इफ योर प्रोसेस रन्स इन द सेंटर एंड विद द मिनिमम वेरिएशन, योर CPK is high, means the chances of going out of control limit is less, the chances of making a non conforming product, खराब प्रोडक्ट बनाने के चांसेस कम हो जाते हैं। ओके, एक्सीडेंट होने के चांसेस कम हो जाते हैं। नाउ टिल नाउ इफ यू हैव एनी क्वेश्चन यू कैन आस्क, देन वी विल मूव फॉरवर्ड। यहां तक किसी को कोई इशू? Then we are going to I will show you the formulas for some of the control charts, and then we will start making the how to make the control charts. Okay, कोई issue नहीं है। So there are basically the formulas. So today we are going to see the X chart, or you can say I chart, individual chart, okay, and MR chart, moving range chart. How to make this IMR chart, we will show you. The formula please note down somewhere. To calculate the LCL, okay, to calculate the LCL, the formula is X bar. X bar का मतलब क्या होता है? What is X bar? X bar is the average. Okay, X means data. In the statistics, please remember X means data, X bar means average of the data, minus 3 R bar by D2. R bar means R is the range, R bar means average, range का average, divided by D2. D2 is the constant. Okay, D2 is the constant, statistical constant. The value of that statistical constant I will tell you when we go to the Excel sheet. And UCL कैसे calculate करोगे? To calculate the UCL, you need to use this formula. X bar plus 3 into R bar by D2. And for MR chart, it is 0 and D4 MR bar. Little bit confusing, little bit difficult to understand. Okay. But if you practice, जब आप practice करोगे तो आपके समझ में अच्छे से आएगा. You need to play with the data. जो स्टैटिस्टिकल कंसेप्ट है उसको समझने के लिए यू नीड टू प्ले विद द डेटा, यू हैव टू टेक द डेटा ऑफ योर प्रोसेस एंड यू हैव टू स्टार्ट डूइंग समथिंग, यू नीड टू स्टार्ट प्रैक्टिसिंग दैट वन. So any question here so far? Okay, so I chart basically, in the I chart, it is basically IMR chart, individual moving range chart. Okay, it is called IMR chart, individual moving range chart. So in the I chart, when you plot the I chart, it's a combination. It's a combination of the individual data and the moving range data. So in the I chart or X chart, it is X bar, that is averages, minus 3 into R bar by D2. And the LCL, it is X bar minus 3 into R bar by D2. And UCL, X bar plus 3 into R bar by D2. So LCL, when we say X bar, means whatever the data is there, uska average. We need to take the average of the entire data. When we go to the Excel sheet, you will understand in a better manner. And then you need to minus the 3 into R bar by D2. So what is this R bar by D2? The range, data range average divided by D2, and X bar plus 3 into R bar by D2. So now what I'm going to do, we are moving to the Excel sheet. I will show you how to make the IMR chart. Okay. How to calculate. Basically, making a chart means calculating the LCL, UCL average line, and then keep on continuously plotting the data on the shop floor on the graph paper. Okay, over a graph paper. Okay. Now, just to let you know, the constant D2, when you have individual moving range data, individual moving range basically, the constant D2 is 1.128. Somewhere you note down. Now you can see the Excel sheet. Can you see the Excel sheet? Yeah. R bar by D2, Virendra, R bar means रेंज है, रेंज का एवरेज. अब रेंज कैसे कैलकुलेट करोगे? सो जस्ट फोकस हियर नाउ, है ना. Now you have a 25 number of data, for example. Okay, you have 25 number of data, not maximum. Okay, the 25 number of data are there. It is a temperature data, temperature of a process. Now you need to find out the LCL and UCL of this data. Got it? First thing is the average. So average is very simple. You calculate the average of the entire data. Average, AVERAGA formula, and you put on to, no, it is not minimum divided by 2. Na? Average means the sum of all the data divided by the number of data. जितना डेटा है उसका एडिशन डिवाइडेड बाय कितना डाटा है, 25 डेटा. सो दैट इज द एवरेज. तो यहाँ पे एवरेज कितना है? 100.36. नाउ जस्ट टेल मी व्हाट इज द एवरेज ऑफ 2, 4, 5, 8, 7, 4. What is the average of this one? Calculate and tell me now. What is the average of this data? Yes, Upender saying 5. Anybody else? What is the average of this data? जो आपके सामने रखा है मैंने अभी. Very easy, है ना? I mean, we don't need any special skill. So how you calculated the average? One is directly, okay, I will use the formula from the Excel sheet. Okay, and it will give me the answer, that is 5. Virendra, it is not 20. Okay, average is not 20. एवरेज कैलकुलेट करने के लिए आपको क्या करना पड़ेगा? सबका इसका एडिशन 2 प्लस 4 प्लस 5 प्लस 8 प्लस 7 प्लस 4, कितना हुआ? 30. और कितने डाटा है अपने पास टोटल? टोटल डेटा इज 6. सो 30 को 6 से डिवाइड करोगे तो आता है 5. सो एवरेज क्या होता है? जितना भी डेटा है उसका एडिशन और उसको नंबर ऑफ डेटा से डिवाइड करोगे, एवरेज है ना. कितना एवरेज मार्क मिला हमको? तो सभी सब्जेक्ट में कितने मार्क्स मिले और कितने सब्जेक्ट थे. गॉट इट? सो दिस इज द एवरेज वैल्यू. नाउ क्योंकि मुझे ग्राफ बनाना है, आई विल कंटिन्यू राइटिंग दिस एवरेज टिल 25, है ना. यहां तक मैं उसको. सो एवरेज इज हाउ मच? 100.36. So average is nothing but X bar. Okay, X bar is the average. Got it? Now range कैसे निकालेंगे? How we are going to calculate the range? Range क्या होता है? Range is basically a difference between the two consecutive points or a set of data. अगर मुझे ये दोनों का बीच का डिफरेंस निकालना है, so what will be the range? I will minus it. Okay. So 101.3 minus 100.1. So the range is 1.2. These two datas are 1.2 units away from each other. Then how much this away from 101.3? कितना दूर है ये? So again I will make. So it is minus 1.1. Okay. So I continue to make this. So this is the range of the data. जो हमारा डेटा का रेंज है इतना है, बट मैं ये माइनस नहीं ले सकता हूं इसमें, ठीक है. आई कैनॉट टेक द माइनस वैल्यूज ऑफ दिस वन, बिकॉज व्हेन आई वांट टू मेक द एवरेज, व्हाट विल हैपन, माइनस प्लस एक दूसरे को एनिलेट कर देगा और मुझे एवरेज प्रॉपरली नहीं मिलेगा रेंज का. सो इस वैल्यू को मुझे साइन लेस करना है, मीन्स मुझे सिर्फ 1.1 होना चाहिए यहाँ पे, माइनस 0.3 नहीं, सिर्फ 0.3 लिखना है. तो उसके लिए एक्सेल शीट में देयर इज अ फॉर्मूला एब्सोल्यूट वैल्यू ABS. ओके, ABS करके आप लिख दो. सो इंस्टेड ऑफ minus 1.1 इट विल शो यू 1.1. दिखा आपको यहां पर, दिस इज minus 1.1 बट नाउ इट इज कन्वर्टेड टू 1.1. Instead of minus 0.3, now it has been converted to 0.3. Okay. And then instead of minus 0.1, it has been converted to 0.1. Instead of minus 1.2, it has been converted to 1.2. Instead of 2.6, okay, 2.6 is there. So minus का automatically plus में चला गया, signless हो गया basically. Because otherwise मैं इसका जब एवरेज करूंगा प्लस माइनस एक दूसरे को एनिलेट कर देंगे, है ना. नाउ ये सबका जो रेंज है उसका एवरेज कैसे निकालूंगा मैं? अगेन सेम थिंग, जो रेंज है उसका एवरेज निकालूंगा मैं, एंड दैट इज नथिंग बट अ आर बार, है ना. 0.9333 इज द आर बार. अभी समझ में आया रेंज आर बार क्या है, एक्स बार क्या है, समझ में आ गया आप लोगों के? यस और नो? Okay. Now you have the value of x bar. You have the x bar is 100.33. You have the value of r bar, and now you require a statistical constant called D2. ये दो के बीच का डेटा मैंने एज अ रेंज लिया, हर एक दो वैल्यू का डाटा का रेंज लिया मैंने, इसलिए द D2 is 1.128. So what is D2? 1.128 is the D2. ठीक है. नाउ आपके पास तीनों वैल्यूज हैं, ठीक है ना. आपके पास x बार है, आपके पास r बार है, और आपके पास D2 की भी वैल्यू है, दैट इज 1.128. नाउ प्लीज कैलकुलेट LCL and UCL for this data. फॉर्मूला आपके पास है. नाउ यू नीड टू कैलकुलेट, जस्ट यूटिलाइज दिस फॉर्मूला. हाँ, यस राहुल.
Sir, can you please explain D2 once again?
D2 is basically a statistical constant, okay, and depending on the sample size means not 25, okay, this is 25 samples you have taken, no, not that sample size. रेंज आपने कितने इसका निकाला, रेंज जब निकाला आपने, कितने वैल्यू का रेंज निकाला आपने? रेंज निकालते हो कितना डाटा यूज किया आपने इस रेंज को निकालने के लिए? 2, है ना. जब आपने ये, हाँ 2, जैसे आपने 1.2 जो रेंज है, ये दो डाटा के बीच का डिफरेंस, ये दो डाटा का बीच का डिफरेंस, देन इस 2 डाटा के बीच का डिफरेंस, दैट इज बेसिकली अ रेंज. सो रेंज के लिए आपने दो डाटा यूज किया, दैट्स व्हाई यू नीड टू यूटिलाइज द कांस्टेंट फॉर 2. जब हम सब ग्रुप की बात करते हैं, सम टाइम व्हाट यू डू, आप 5 डाटा लेते हो एक साथ, 100 में से आपने 5 डाटा डाल दिया वहां पे, अब आप उसका जब रेंज निकालते हो 5 डाटा का, दैट टाइम यू नीड टू टेक द D2 वैल्यू ऑफ 2.236.
Yes, sir. I understood, sir.
Okay na? हाँ, yeah. So now you have D2 value, you have R bar, you have X bar, everything is there, formula is there. Now please calculate the LCL and UCL and share with me now. Calculate on a piece of paper. Birendra, you don't go to the D4 right now, okay? We are just discussing eye chart. Right? You have to focus on this only. D4 I will explain you later on. Right? Now you just make the eye chart. Okay? You focus on this. This we will, next step is this one. So, Upendar already calculated. Yeah, no problem. You know, trying is okay, Upendar. You know, right, wrong, that is not a question. So, Upendar is saying 72.715. Okay, 72.715 and 128.005. This is the answer of Upendra. Anybody else? If you are calculating, okay, keep on. But what I will do, I am going to show you the answer. You can tally your answers with that. Okay. Now the value of the R bar. What is the value of the R bar? Is 0.9333. So I have taken this here directly from this value. I have written here. D2 is 1.128. So R bar by D2 is this one divided by 1.128. So R bar by D2 is 0.8274 and X bar ki value is 100.36. So now calculating the LCL for this one is X bar, okay, minus 3 into R bar by D2. This is the value of R bar by D2. So LCL is 97.878. Okay. And what is the UCL? UCL will be X bar plus 3 into R bar by D2, 102.84. So this is the answer. Now just check, Upendra, where you have done the mistake. Why your answer has come 72.715. maybe the placement of the things. Basically, maybe you have done x bar, you have taken rightly 100.36, and then minus will be 3 into r bar by d2. R bar by d2 is 0.8274. Okay. So this is the LCL and UCL for the individual chart. Okay. LCL and UCL for the individual chart. Now, what about the MR chart? Now, MR chart, the LCL will be 0 because range you want, the lower is the better. So 0 is the range, LCL for the range chart. But for the upper control limit, you have D4 MR bar. Means MR bar means moving range, or you can say R bar. M is nothing, it's called moving range. So R bar and MR bar is same. Okay, it is same. Now D4. So the D4 value, again our set of point is 2 only, 2 set of data we have taken the range. So D4 is 3.268. So considering this 3.268 as a D4, R bar is again same, that is 0.93333. What is the UCL then? In that case UCL कितना आएगा? आपको सिंपल है, D4 को मल्टीप्लाई करना है R बार से. D4 की वैल्यू है 3.268 और R बार की वैल्यू है this one 0.93333. So now calculate quickly. It's a simple calculation. 3.268 multiplied by R bar 933.933, or you can say 0.934. कितना आएगा? Simple calculation, do it quickly. Are you people calculating? You see D2 जो है ना, D2 वैल्यू आपको यूज करना है ऊपर के लिए, और D2 यहाँ पे दिया है 1.128, तो आपने यहाँ पे यूज करना है उसको ऊपर वाले फॉर्मूले में. ठीक है वीरेंद्र? D2 की जो वैल्यू है वो स्टैटिस्टिकल कांस्टेंट है. आपने रेंज लिया दो डाटा का, इसलिए आपको D2 की वैल्यू लेना है. दो के अगेंस्ट कितना है? 1.128. ठीक है. और D4 की आपको कैलकुलेट नहीं करना है. यू डोंट नीड टू कैलकुलेट द D2 एंड D4. वो स्टैटिस्टिकल कांस्टेंट्स है. ओके, इट्स द स्टैटिस्टिकल कांस्टेंट. यस वैष्णवी, यू हैव एनी क्वेश्चन?
सर यदि
हाँ बोलो बोलो.
सर D2 की वैल्यू निकालनी तो वह कैसे निकालूंगा सर? मुझे अभी तक डाउट क्लियर नहीं हुआ सर.
D2 is 1.128. इट इज अ स्टैटिस्टिकल कांस्टेंट. आपको नहीं निकालना है वो. आप कोई भी डाटा यूज करो, जब आप रेंज निकालोगे दो डाटा से, दो डाटा का लेके रेंज जब भी निकालोगे, यू नीड टू टेक दिस कांस्टेंट. इट इज अ कांस्टेंट. कांस्टेंट है, वो चेंज नहीं होता है कभी. जब कभी आप दो डेटा का रेंज लेते हो ना, दो डेटा का, ठीक है, when you are making D2 is a constant, D4 is a constant. बेसिकली वो कांस्टेंट है, वो स्टैटिस्टिकल कांस्टेंट बोलते हैं उसको. इट इज नॉट गोइंग टू चेंज. यू टेक एनी डेटा. अगर आप जब रेंज निकालते हो दो डेटा का, ये दो डेटा का बीच का रेंज निकाल रहे हो ना, okay, then it is called, then you have to take the, this is the two sample, you are taking the data of two sample, you are calculating the range out of these two sample. That's why you need to take this constant of D2 and it is 1.128. आपको स्क्रीन दिख रही है ना मेरी? Screen is visible to you people?
Yes, sir.
Yes. So it is already given. I'm the D2 is agar if you take three data, okay, if you are taking three data and you are calculating the range out of that, then the D2 value will be 1.693. But the data placement will not be like this. Okay, इस तरह से डेटा नहीं होता है, उसका डेटा अलग तरीके से होता है. फॉर एग्जाम्पल, लेट मी मेक यू अंडरस्टूड. In that case, you are going to go into the subgroup size. Okay, you go into the subgroup. अब वो और आगे की, that's why I tell you ना, it is a not that easy topic. And this subgroup क्या होता है, ये सब चीजें हम एसपीसी का जो ट्रेनिंग प्रोग्राम है 9 आवर्स का, उसके अंदर बताते हैं. फॉर एग्जाम्पल, आपने वन है ना, आपने सैंपल वन, आप हर घंटे में 5 सैंपल का डाटा ले रहे हो. फॉर एग्जाम्पल, ओके, एवरी आवर यू आर टेकिंग द 5 सैंपल्स, डेटा ऑफ 5 सैंपल. सो आपने 8 AM को, 9 AM को, 10 AM को, 11 AM को आप डेटा ले रहे हो 5 सैंपल का. ठीक है, देयर माइट बी हंड्रेड्स ऑफ सैंपल, बट आपने 5 सैंपल का डेटा लिया. अब 5 सैंपल का जो टेम्परेचर था या फिर साइज थी, फॉर एग्जांपल उसका साइज था 95, 99, 97, 98, 94. These are the 5 samples. Now इसका रेंज बताइए, how you will calculate the range of this one? How will you calculate the range? रेंज क्या होगा इसका?
Difference between the two samples.
Which two sample? The maximum and the minimum. So the range will be minimum sample कौन सा है, maximum what is the range basically of this data? ये डाटा कहाँ से कहाँ तक फैला हुआ है ना, that is the range. So if I make this plot like this one, है ना, just for your understanding, your range will be, सबसे कम पॉइंट कौन सा है, this one, and सबसे ज्यादा कौन सा है, this one. This is the range. आपका मिनिमम टेम्परेचर, आज का जो टेम्परेचर था आपकी सिटी में, इट वाज 32. दोपहर में मैक्सिमम टेम्परेचर वेंट अप टू 45. व्हाट इज द रेंज ऑफ द टेम्परेचर? योर टेम्परेचर रेंज इज 13 डिग्री सेंटीग्रेड का टेम्परेचर रेंज है आपका. 13 डिग्री सेंटीग्रेड से आपका टेम्परेचर वेरी होता है कम और ज्यादा के बीच में. ठीक है. नाउ व्हेन यू take a subgroup data like this one, now your sample size is 5, you calculate the range.
Five, sir.
है ना, डायरेक्टली अगर कर लेते हैं तो 99 और 94, so your range is 5. So it's a difference between the 99 and the 94, so your range is 5. Okay, now when you are taking these 5 samples, now don't confuse with this 5, let me change it to some other value, otherwise what will happen, you will confuse that with now it is 6. Okay, now in this case, what is the D2 value you will take? What is the D2 value for such data? The D2 value for such data will be 2.326. Basically is 2.326 because you are 5 samples, you are taking the range of the 5 samples. So you will have various data like this one, and then you will calculate the range ka average, that will be your R bar. Okay, तो ये जो रेंज निकाल रहे हो आप, you are taking the range from this 5 samples. So your D2 value will be corresponding to the 5. Virendra, please mute yourself. There is a background noise. And D4, again D4 the same thing. If you are utilizing the two data for calculating the range, use 3.268 as the D4. If you are taking 4 samples, you are taking 5 samples, use corresponding D4 value. It is a statistical constant for any number of data, for any kind of data. It depends on how many samples you are taking for calculating the range. It is basically a subgroup size. Got it? Any confusion? Still there is any confusion? Is it clear now or no? Okay. So basically now you have the LCL, UCL, and you have a average, and you have the data. And this is what you want. This is what you require for making a chart. So you have the data, you have the average value, you have the LCL. What is the LCL now? The LCL is for individual chart 97.87, and UCL is 102.84. Okay, so I will just why I am making this to make the graph, because LCL and UCL आपको पूरे रेंज में दिखाना पड़ेगा. वीरेंद्र, डू यू हैव एनी इशू अगेन? कुछ समझ में नहीं आया अभी भी? एंड रेंज चार्ट के लिए जो LCL है दैट इज 0, एंड UCL जो रहेगा D4 इंटू आर बार. नाउ D4 की वैल्यू है आपकी 3.268, 3.268 इंटू आर बार. आर बार आपका है दिस वन. तो दिस इज योर 3.05 इज द. So now you will make the UCL and LCL for the R bar also. Now you need to plot the data. So there are two different charts you are going to prepare. दो अलग अलग चार्ट बनाओगे. एक तो बनाओगे इंडिविजुअल डेटा का, ठीक है, दैट इज कॉल्ड आई चार्ट, इंडिविजुअल डेटा चार्ट. आप इंसर्ट करोगे, ग्राफ में जाओगे, एक ग्राफ बनाओगे. दिस इज द इंडिविजुअल चार्ट, दिस इज द डेटा. नाउ अब आपको इसके ऊपर क्या डालना पड़ेगा? यू नीड टू इंसर्ट द UCL and LCL data. So this is basically a data. Then you will add LCL. You will go, and what is the LCL? LCL is this one. Okay, आपका LCL का डाटा आ गया. Now you will add again. You will make the UCL. And what is the series of the UCL? UCL series is this one. Now what is the average? You will put the average data. Average कितना था हमारा? 100.36. This is 100.36. So आपका चार्ट तैयार हो गया. This is a basically a IM chart, individual, not IM chart, individual chart, I chart. Okay. Now आपका रेंज जो है, you are going to calculate the range chart. Now रेंज के लिए अगेन, रेंज का डेटा क्या था हमारा? This is the data of the range. तो आप उसको ग्राफ बनाओगे. Again you will add the LCL and UCL. LCL is nothing but a 0. And This is the data of the range. This is the UCL. UCL of the range chart is this one, and the average of the range, R bar. What is the R bar? 0.9333 is the average. This is now your range chart. Now you need to plot it on the same graph. ओके आपको एक ही ग्राफ पे बनाना है उसको साइड बाय साइड. अब आप देखेंगे ये दोनों का जो रेंज है वो इसको करस्पॉन्ड करेगा यहाँ पे. ठीक है, क्योंकि यहां से शुरू होगा जो करस्पॉन्ड करेगा इधर. क्योंकि आपको रेंज कब मिलेगा? जब पहले दो डाटा होंगे आपके पास, तभी रेंज मिल सकता है आपका, है ना. फिर ये जो दो डेटा के बीच का रेंज कहाँ पे आएगा? दिस इज द रेंज फॉर द नेक्स्ट टू डेटा. देन ये डेटा का रेंज कहाँ पे है? दिस इज द रेंज फॉर द. सो नाउ आपके सामने ग्राफ है. नाउ जैसे जैसे डेटा कलेक्ट होगा, एज यू स्टार्ट कलेक्टिंग द डेटा, यू नीड टू प्लॉट इट कंटिन्यूअसली. आप डेटा प्लॉट करते रहोगे, जो भी आप डेटा कलेक्ट कर रहे हो दैट यू आर गोइंग टू प्लॉट, और आप यू विल मॉनिटर दिस ट्रेंड. समझ में आया? You are going to monitor. This is how you will prepare. Now you need to prepare it on a piece of paper. You need to prepare it on a piece of paper. On a piece of graph paper. And then you have to display it on the shop floor. और जैसे जैसे आप डेटा कलेक्ट करोगे आपको ये डेटा वहां पर डालना पड़ेगा. ठीक है, आपको ये डेटा वहां पर डालना पड़ेगा. और यू विल मॉनिटर द ट्रेन एंड टेक द एक्शन. आपको पता चलेगा आपकी गाड़ी कहाँ जा रही है, यहाँ पे है, यू विल टेक सर्टेन एक्शन, है ना. सडनली ऊपर जा रहा है, यू विल टेक सर्टेन एक्शन टू ब्रिंग इट टू द सेंटर. गॉट इट? कोई इसके अंदर इशू? एनीथिंग दैट यू नॉट अंडरस्टूड? कोई चीज समझ में नहीं है तो यू कैन आस्क. ओनली थिंग दैट आई कैन टेल यू इज यू नीड टू प्रैक्टिस. जब तक आप डेटा नहीं लोगे कोई, आप उस डेटा के साथ प्ले नहीं करोगे. यू हैव टू ट्राई टू मेक द चार्ट्स, है ना. यू नीड टू ट्राई टू मेक द चार्ट्स, देन ओनली यू कैन मास्टर इट. नाउ आई एम चेंजिंग द स्क्रीन टू द प्रेजेंटेशन. So these are the various control limit formulas for various charts. अगर आपको एवरेजेस रेंज चार्ट एक्स बार आर चार्ट बनाना है, तब जो D2 की वगैरह वैल्यू है ना, तब अलग अलग आती है. दैट टाइम यू नीड टू मेक H डबल बार A2 R बार और H डबल बार प्लस A2 R बार. R चार्ट R बार बाय D3 R बार बाय. सो देयर आर वेरियस फॉर्मूलाज, और ये आपको डिटेल में तब पढ़ने को मिलेगा इफ यू ज्वाइन दैट SPC कोर्स. और नॉट ओनली द कोर्स, यू कैन सर्च इट ओवर द इंटरनेट इफ यू हैव दैट क्यूरियोसिटी अबाउट ऑल दिस थिंग. आपको ट्राई करना पड़ेगा. यू नीड टू प्रैक्टिस दिस इन डे टू डे. फिर NP चार्ट के अलग फॉर्मूलेज है, C एंड U चार्ट के अलग फॉर्मूलेज है. सो दीज आर एवरी चार्ट हैज अ डिफरेंट फॉर्मूला. जिस तरह से हमने बनाया है उस तरह से आपको बनाने पड़ेंगे. नाउ एवरी प्रोसेस टेंड्स टू डिटोरिएट. कोई भी जो प्रोसेस होती है ना, जैसे आपके वेकिंग अप की प्रोसेस है, सिंपल प्रोसेस, इट टेंड्स टू डिटोरिएट मींस ओवर अ पीरियड ऑफ टाइम आप थोड़ा 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 लेट उठते हो, है ना. 1 मिनट, 2 मिनट, 3 मिनट, 4 मिनट, ऐसा करते 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 यू टेंड्स टू woke up late. So every process tends to deteriorate, and control charts are simple and effective tool to detect this degradation of the process and take timely action. Now, if you monitor your wake up time every day on a control chart, You will come to know whether you are continuously waking up late. If you find that yes, you are continuously waking up late by 1 minute, 2 minutes every day, you will take the action before you go out of control limit. You will realize ki, oh, I am waking up late every day. Now I need to correct the timing. I need to wake up fast, wake up early, so that there should not be so much of variation. So that is the beauty of the control chart, है ना. इस तरह से आप अगर कंट्रोल चार्ट को यूज करते हो तो इट विल शो यू, इट विल टेल यू कि कहाँ आपकी प्रोसेस डिग्रेड हो रही है और आपको प्रॉम्प्ट करेगी टाइमली एक्शंस के लिए. यू विल स्टार्ट टेकिंग द एक्शंस. नाउ कंट्रोल चार्ट की जो थी एक्सरसाइज हमने ऑलरेडी कंप्लीट कर दी है वो. ओके. नाउ व्हेन यू वांट टू यूज द कंट्रोल चार्ट, जैसे मैंने बताया, व्हेन यू वांट टू यूटिलाइज इट फॉर मॉनिटरिंग द ऑनगोइंग प्रोसेस, when you want to predict the expected range of outcomes from a process, when you want to check whether your process is in a state of statistical control or not, आपकी प्रोसेस स्टैटिस्टिकल कंट्रोल में है या नहीं है, मींस स्पेशल कॉजेस उसके अंदर नहीं है, ये चेक करने के लिए आप वेरियस वेरिएशंस के पैटर्न्स मॉनिटर करने के लिए इसको यूज करते हो. नाउ द कंट्रोल चार्ट एप्लीकेशन इज, यू वांट टू establish the state of statistical control, you want to monitor your process, and you want to get the signal whenever it goes out. जब भी ये बाहर जाएगी, you will come to know visually, then determine the process capability. उसके लिए आपको यूज होगा. इसको अगर आप देखोगे, है ना, इट इज अ स्पेशल कॉज पैटर्न्स फ्रॉम द कंट्रोल चार्ट. ओके. जो मैंने आपको बताया स्पेशल कॉज, जरूरी नहीं कि आप कंट्रोल लिमिट के बाहर जाओ तभी स्पेशल कॉज है. ओके. मैंने आपको बताया ना कि आप कंटिन्यूअसली लेट वेकअप होते जा रहे हो, जल्दी 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 उठते जा रहे हो कंटिन्यूअसली 7 दिन, इसका मतलब देयर इज अ स्पेशल कॉज, समथिंग इज गोइंग, समथिंग स्पेशल इज देयर. स्पेशल कॉज है इसका मतलब ये जरूरी नहीं कि वो खराबी है. ओके. स्पेशल कॉज इट मींस देयर इज सम आइडेंटिफाइबल कॉजेस आर देयर, कुछ ऐसा है जो आपको पता है, उसको आप कंट्रोल कर सकते हो. ठीक है. So there are 8 tools, है ना, और 8 different patterns. अगर कोई भी पॉइंट आपका कंट्रोल लिमिट के बाहर जाता है, इसका मतलब डेफिनेटली वहां पर स्पेशल कॉज है. ठीक है, असाइनेबल कॉज है. देन 7 पॉइंट्स इन अ रो, अप और डाउन, है ना, सेम साइड ऑफ अ कंट्रोल लाइन. 7 पॉइंट अगर सेम साइड ऑफ द सेंटर लाइन है, सेम साइड ऑफ द एवरेज है, 7 बार अगर आपके एवरेज टाइम वेकअप का जो है उसके एक ही तरफ आप हो, ऊपर रहो या नीचे रहो, है ना, एक ही तरफ हो आप 7 बार, इसका मतलब देयर इज अ स्पेशल कॉज. ओके. अगर 7 बार 6 बार कंटिन्यूअसली अप जा रहा है ट्रेन या डाउन आ रहा है ट्रेन, 6 बार कंटिन्यूअसली कहीं से भी जाए, यहां से चालू होके यहां जाए 6 बार, या यहां से चालू होके यहां पे जाए 6 बार, यहाँ पे चालू होके यहाँ पे 6 बार डाउन जाए, देयर इज अ स्पेशल कॉज. सो ये टोटल 8 तरीके के अलग अलग स्पेशल कॉज पैटर्न बताए गए हैं. स्टडी, आप कंट्रोल चार्ट बनाइए, चेक योर कंट्रोल चार्ट. आपके यहाँ पे जो प्रोसेस मॉनिटर होता है, जो भी प्रोसेस हो, जो भी प्रोसेस पैरामीटर्स हो, ट्राई टू मेक द कंट्रोल चार्ट. इफ यू फेस एनी डिफिकल्टी, शेयर द डेटा विद अस, वी विल हेल्प यू इन प्रिपेयरिंग द कंट्रोल चार्ट्स. आप कंट्रोल चार्ट बनाइए and then you start checking the patterns के स्पेशल कॉज तो नहीं है उसके अंदर, और टाइमली एक्शन लेना शुरू कर दीजिए डिपेंडिंग ऑन द पैटर्न. ठीक है. सो एनी डाउट इन द टूल नंबर 3, that is control chart? I told you already that yes, control chart slightly difficult because formulas are involved in that. You know, formulas are involved in that. So it is slightly difficult. Okay. So no questions. So what we do, we will start the tool number 4, that is scatter diagram. Okay. But after a 2 minutes break, है ना. 2 मिनट के ब्रेक के बाद वी विल स्टार्ट दिस टूल नंबर 4, दैट इज स्कैटर डायग्राम. ठीक है. So don't go anywhere, just wait for 2 to 3 minutes and we will start this. Now tool number 4, scatter diagram. है ना. So scatter diagram you must have seen many a time. It is also known as the scatter plot. है ना. Scatter diagram is also known as the scatter plot. And it is basically used to check the correlation between the two factors. For example, like Upender, you are making the explosives in your factory. There might be certain properties. One property might be corresponding to some other factor, है ना. There are certain properties which are time dependent, which depends on the temperature. The strength can be depending on the temperature, the curing time, for example. In case of the tire, the strength may vary depending on the temperature. So it can be a positive correlation, it can be a negative correlation, but scatter plots are basically used to check whether any correlation exists or not. For example, the humidity, the humidity and the rain is proportional. Okay, so for example, in the initial time when the raining starts, the humidity increases. The more you are nearer to the seashore, the humidity will be more. So basically there are certain factors on which other factor is dependent. So whether these two factors are correlating with each other or not, whether positive or negative, that is different thing. Positively or negatively अलग बात है. बट क्या दो फैक्टर का एक दूसरे के साथ कोई रिलेशन है? जैसे कि टेम्परेचर एंड स्ट्रेंथ. जो वायर बनता है फर्नेस में, पेटेंटिंग में, तो the strength will depend on the carbon, the strength will depend on the your temperature of the lead bath. So all these parameters are there. So to check whether the correlation basically exists or not, a scatter plot is used. जब आपने फिशबोन डायग्राम या आपकी जो इशिकावा डायग्राम है उससे जो probable causes निकाले, and now you want to check whether that particular probable cause is correlating with the actual output or not. आपको उसको कुछ जो डाटा बेस्ड फैक्टर्स है, यू नीड टू कोरिलेट कि यस उसके साथ कोई रिलेशन है या नहीं है. सो फॉर दैट पर्टिकुलर पर्पज यू आर गोइंग टू यूज द स्कैटर प्लॉट. जैसे कि हियर यू कैन सी देयर इज द डेटा ऑफ द हाइट ऑफ अ पर्सन and the weight of a person. You can see as the height increases, the weight also increases. There are certain cases where for the same height the weight has increased. There are certain cases, or there are certain cases on the higher height the weight is lower than the previous lower height. So these are the stray cases, because exceptions are also there. Exceptions will always be there. But हमको क्या देखना है? हमको ट्रेंड देखना है कि क्या वो ट्रेंड पॉजिटिव है, क्या वो ट्रेंड निगेटिव है. So basically we can establish that yes, हाइट बढ़ती है तो वेट बढ़ता है, और there is a relation, positive correlation between the height and weight. आपके यहाँ पे जो फैक्टर है आपको चेक करना पड़ेगा. आपके फैक्ट्री में ऐसे कौन से फैक्टर है which can correlate? Yes, Upender, what factor you can correlate with each other? Or you think that yes, they can be correlated? Okay, no. Another example, it's a day-to-day life example I am taking. You are yes, Upender, no issue. The mean body fat percent Okay, the fat percent, our fat percent basically, no issue, Penda. The mean body fat percent means the fat content in our body, okay, increases with the age, है ना? So mean body fat percent, you can see that yes, it has increased, है ना, with the our age. And mean BMI, that is body mass index, जो बॉडी का मास इंडेक्स है, BMI जो होता है, you will see that up to a certain level, certain years, this is the age in the years, up to certain years of age, it increases. 40 to 60, the BMI is constant, and after that, it starts reducing. The BMI will be lower. Okay, the BMI, the body mass percent, the body mass index, not percent, body mass index decreases after a particular age. So basically here what we are correlating, क्या हम correlate कर रहे हैं, BMI को correlate कर रहे हैं हम years, age के साथ. वैसे ही हम correlate कर सकते हैं हमारे industrial factor, the industrial various factors, temperature, strength, the productivity with the shifts, and productivity with the you can say the input material, the number of problems that you are getting with the number of what kind of raw materials you are utilizing. So all these things can be correlated, and then you can see whether they have a positive or the negative correlation. Now, how you are going to make a scatter diagram? There are two ways. Okay, there are two ways. One, manually you can do, and another one, directly you can do it using the Excel sheet or utilizing the various statistical analysis programs. Okay, like Minitab, R, Python, all these things you can use. Now we will learn the basics first, and we will see how you can do it manually. Number one thing will be to collect the pair of data where the relationship is suspected. So जो भी डेटा हमको कोरिलेट करना है, आपको लगता है कि यस द स्ट्रेंथ एंड द टेम्परेचर इज कोरिलेटेड, ओके, द अमाउंट ऑफ मिक्सचर यू आर एडिंग द एंड द एक्सप्लोसिविटी ऑफ दैट पर्टिकुलर मटेरियल is correlated, ऐसा आपको लगता है, you are suspecting, then you will collect that data. On the x-axis, that is horizontal axis, you will have the independent variable, means for example hardness and the temperature. Okay, temperature and the hardness. Now you know your temperature is not depending on the hardness of the material, but hardness is depending on the temperature. So in that case, temperature will be on the x-axis, and the hardness, which is a dependent variable, हार्डनेस किसके ऊपर डिपेंड है, टेम्परेचर के ऊपर डिपेंड है. सो इन दैट केस यू विल पुट हार्डनेस ऑन द वाई एक्सिस. नाउ फॉर ईच पेयर ऑफ डेटा यू विल पुट अ डॉट. फॉर एग्जांपल टेम्परेचर कितना है, 902 होगा, and your hardness is 50, so you will plot one point here. Then at temperature of 900 the hardness is 51, you will plot a point here. So ये जो डेटा है, ये दो डेटा का जो करस्पॉन्डिंग्स है, वहां पे आप एक पॉइंट ड्रॉ करते जाओगे, मींस पॉइंट आप लगाते जाओगे. तो बेसिकली ये जो डेटा है, ये जो पॉइंट है, ये करस्पॉन्ड किसको करता है, दिस टेम्परेचर एंड दिस हार्डनेस. ठीक है, ये जो पॉइंट है ये किसको करस्पॉन्ड करता है, 912, 13 समथिंग एंड अ हार्डनेस ऑफ 57. तो आप इंडिविजुअल पॉइंट्स को वहां पर ग्राफ पे लगाओगे. नाउ sorry, now you will see कि if you can clearly see the correlation, आपको क्लियर कट दिखता है ऐसे, जैसे यहां पर है ना, आप देखो you can see a clear cut correlation. There is no need to do any analysis, you know, yes, as the temperature increasing, hardness also increases. Now, what you can do next, whether it is scientifically correlated or not, for that there is a procedure. Okay, manually how you can do is, जो भी पॉइंट्स है, टोटल पॉइंट्स, उसको आपको डिवाइड करना है. ठीक है, अगर आपको कोरिलेशन दिखता है ठीक है, अदरवाइज आप ये 4, 5, 6, 7 जो स्टेप्स है उसको कंप्लीट कीजिए. आपको पॉइंट्स जो है ग्राफ पे उसको डिवाइड करना है हॉरिजॉन्टली एंड वर्टिकली. सो ये जो टोटल पॉइंट्स थे, है ना, टोटल पॉइंट्स कितने थे यहाँ पे? 32 पॉइंट्स है. इफ यू काउंट इट, देयर आर 32 पॉइंट्स. सो आई विल पुट अ हॉरिजॉन्टल लाइन, 16 points on this side, 16 points on this side, and I will put a horizontal line, 16 points above this line and 16 points below this line. These are 16 and these are 16 above the line. Okay, and if I check it vertically, these are 16 and these are 16. So you need to make it half. If an odd figure is there, if 33 points were there, what you will do? You will make 16 one side, 16 another side. The line will go through one of the point. Okay. You will divide the quadrants into 4 quadrants. You will name it A1 and A2. This is A1 and opposite one is A2. And this is B1 and opposite is B2. These are the 2 quadrants you have. Got it? And now you note down how many points are there on each quadrant. Like A1 you have 1 point, B1 you have 15 point, A2 you have 1 point, B2 you have 15 points. Got it? Now what is A? A is A1 plus A2. So what is the value of A in this case? A is basically point in the upper left and point in the lower right. So what is A in this case? A क्या है? A1 plus A2. कितना आएगा ये? 2. And B is basically B1 plus B2. So what is B? B1 plus B2. कितने कितने पॉइंट्स थे? 15 तो टोटल कितने हो गए? 30. Q is the smaller of A and B. अब ये दोनों में से छोटा कौन है? 2 is the small. So the value of Q is 2. And what is N? N is A plus B. That is 32. यहां तक समझ में आया? any confusion, any clarification you require till this? You need to calculate the Q and N basically. The N is 32, Q is 2. Why the Q is 2? Because A is 2 and B is 30. The lower of A and B is Q, that is 2. Okay. Now what you have to do is look up the limit for N on the train table. अगर आपका Q, if your Q is less than the limit, the 2 variables are correlated. If Q is greater than the limit, these are not correlated. It has happened by a chance. Now we are moving to the train test table. This is the train test table. What was the value of the Q? What is the value of the N? It was 32. So it is between 30 and 32. And what is the value of N? It is 9. And what was the Q? The value of Q was 2. And 2 is less than 9. It means it is correlated. The data is correlated. ठीक है? As Q is less than the limit, the data is correlated. Similar way, for another example, we have total 12 number of data here, where A1 is 1, A2 is 1, B1 is 5, B2 is 5. Not necessarily every time it will be like that. Sometimes it can change. Now tell me, what is the value of A? It is 2. And B, it is 10. 5 plus 5. So Q will be lesser than this 2. That is 2 is the less. And what is N? Summation of all points A plus B, that is 12. Now we will go to the trend test table again. And here we will see total number of points were 12. So it comes under this. And what is the limit value? 2. And what is the value of Q? It is also 2. So it is equal to or greater than, it means the value of Q is equal or greater than the limit value, means the correlation exists because of some random chance. So correlation doesn't exist. If you look at the graph, you can see it is very scattered. The correlation doesn't exist. You cannot say oh, it is increasing. Okay, nor you can say it is decreasing. Clear cut, you cannot say anything here. Or positive correlation is not there. Very positive correlation. So it is a randomly it is happening for this particular data, you can say so. Is it clear to you people how you are going to check it from the trend test table? It is one of the method. You can up to 90 data. Normally people can follow this. Okay, because 90 data it is you can handle. But if data is in hundreds or thousands of data is there and you want to see the correlation, you cannot go by the manual method. You need to use the Excel sheet or you need to use any other statistical tool program for that one. Any doubt? Let me know if you have any doubt. Okay. So now we will move to the how you are going to make a scatter plot on the Excel sheet. Also, I will let you know how you can plot your equation and what is the significance of this R square value. Got it? So let us go and start preparing a scatter plot for the data of temperature and the hardness of a component. Okay. So I am moving to the Excel sheet. And we will move to the this one. It has already been done earlier, so but we will make it again. Okay. So this is the data. The data you must be having, the x-axis and y-axis data. You need to decide temperature is independent, hardness is dependent. So temperature will go on the x-axis and your hardness will go on the y-axis. Now this data is there, 25 data is there. एक दूसरे के सामने आपने उसको रख दिया, you plotted it उसके सामने. Now what you are going to do is plot a. So I am going to go to the insert. I have selected the data. I went to the insert and in the chart I went for the this one, that is the scatter. Here you can adjust this axis little bit because the value is minimum 40 you can go, so that you can get some better visualization. Okay. Now from the data itself you can see it is correlated or not. Can you say yes, it is correlated just by looking at the trend? Can you say so? It is correlated or not? Can you say it is correlated?
Yes or no? But now you will prove it how it is correlated. You have go to the, you right click on the points, you go to the format data, put on the add trend line. Okay, click on the add trend line. So what you will do, you click on any point, you click right, you right click and add trend line. Okay, here you go to the linear, and here you have the option. Now depending on the what kind of program you are using, what version of the Excel sheet, MS Office you are using, the menu can be little bit different. You have to display equation on the chart, and you have to display R squared value on the chart. Okay, now this is the equation and this is the R squared value. Okay, now you can see this R squared value here on the graph itself. You see what is the R square value? The R square value is basically 0.977. It means it is very strongly correlated. Okay, strongly correlated. The data is very strongly correlated because R square value is this one. Normally anything above 0.9 very strongly correlated. In case of the data related to the calibration, it has to be 0.99. What it shows? It shows it is very closely correlated. Now let me tell you how this R square value will change. Okay, the more data is near to this ट्रेंड लाइन, जितने ज्यादा डाटा इसके पास में रहेंगे, the more closer this data to the trend line, the R square value will increase. Okay, you see this data is slightly away. Got it? Normally for the 916 temperature, the value is at 59. Okay, but if I change it to 58, this value only, you know, one value I am going to change. This value I am going to change and bring it here, just to tell you how this is going to affect the R square value. You know, one point I am going to change, where the combination of 916, okay, 916 and 59 is there. So instead of this, I am going to make it 58. Now R square value, just look at the R square value, 0.977, 0.9799. It has changed to 0.9799. These 2 points, these are very much away. Okay, these 2 points are very much away. What is that? A 51. Okay, 51 at the value of 901 temperature and 902 temperature. The 51 at 901 and 902, I am going to make it at say 51.5 and 52. Okay, so it is 900 is this one, 901 is 51, so I am going to make it 51.5. Okay, and now you see your value has changed to 0.98. 9813, and this point where it is 902 is there and 51 is 52 is there, 51 is there and 902. Yeah, I'm going to make it 52. 0.9838. You see, it was 9779. It has changed to 0.9838 only by changing few of the points. Got it? So more it is closer, your R square value will increase, and more it is away. Just एक point देखिए 907 का 55 है. I am going to make it 59. You see the R square value कितना हुआ? Just by changing one point, by making this value far away, okay, जो 907 55 की value थी, this one, okay, I am going to make it 59. You check it, one point has gone here and your correlation has gone down. If I make certain points like this, your correlation will be lower and lower because more of the points are away from the trend line. Got it? So R square value, you have to look at the R square value. If your R square value is nearer to the 1, you have a strong correlation. Above 0.9, okay, if relation will be there, a strong correlation will be there above 9 also. But if you are making a scatter plot for the calibration purpose, it has to be 9 plus. Okay. You know what I mean by the calibration data? If you have the data of the standard unit you are using for the calibration and your equipment. For example, weight. If the standard, the calibration equipment is saying 100 kilo, what is your equipment showing? It should show 100.1 or 100, nearer to that one. Like if it is a 200, then 300, you are checking or calibrating your weigh bridge of 1 ton. These are the various points at which you have taken the. So now I am going to check the correlation between these two. The data what I and I am going to add the trend line. I am going to display the chart. You see, what is the R value? The R value is 1 because it is very, very strongly correlated. The data is very strongly correlated. If I make a slight changes, 99.3, your data will change. It will change slightly to 99 point. Still, it is very, very strongly correlated. Still, that much data I am changing, but it is strongly correlated. It is not because R square value is still 1 because all data points are, or let me check now because it is 1, still 1. Unless and until I make a big change, like here it is 95, now it is started to go to the 0.9999. Got it? Now it started to fluctuate little bit here and there. Here if I make 895, then it will start this. Got it? So the more stronger the relation is, the points will lie on the trend line. The R square value will be very close to 1. More the R square value, higher the correlation is between the two data points. So basically you need to practice now. You select the data points in your organization, you check, you plot the scatter plot, you check the R square value, you check their relation and see whether they are correlated with each other or not. another data here I have put a speed and the mileage. The mileage is related to the speed. Normally हम बोलते हैं कि if you run this drive a bike or the car at a higher speed or sometimes the low speed also, very low speed, the mileage will be lower. So now you have to see whether they are correlated or not. So you see there is a correlation when you have a lower speed, mileage is low, and the mileage is low at a higher speed also. That is the thing. So basically these two data where you suspect a relationship, you think that yes, there some relationship exists between the data, you can make a scatter plot. Any doubt you can ask me? Now what kind of correlations are there? It can be a positive correlation. It means x and y are moving in the same direction. X increases, y also increases. That is called positive correlation. X increases, y also increases. Positive correlation. This is a negative correlation. X increases, x is going one side, y is going one side. Means x is increasing, but y is decreasing. This is going down. As you increase the x, y is decreasing. X in the sense, x axis. Y in the sense, no correlation. Don't know where the x and y is. Miscorrelation. It can go, it can increase up to a certain level with the x, and after that it start decreasing with the increase in the x, or with the increase in the x it start decreasing, and then with the increase in the x it starts increasing. So it can be a mixed correlation also. First a positive and then a negative, or a negative and then a positive. These are the various kinds of correlation patterns you can have. Then when you are going to use it, like I already told, whenever you suspect there is some correlation is suspected between the two variables, you are going to use it. When you want to identify the potential root causes of the problem, that time you use it. When you want to check whether the probable causes which you have identified on the cause and effect diagram are actually resulting into the problem or not, so that correlation you can do. There are certain things you need to consider. Even if scatter diagram shows the relationship, don't always say that the increase in one parameter is caused because of the another parameter. It can be like it can be influenced by certain other factors also, or it is just because of certain kind of, say it is just a chance, by chance it might be there. You can't correlate anything with anything. There has to be some logical, technical input behind that. Like if I say the number of visitors come to your factory and you start correlating it with the productivity, you will see certain correlation. Sometime it might happen that number of visitors has increased and your productivity also increased, but actually they are not correlatable. There is no correlation at all. Okay, so carry out the correlation exercise for which technically there is an input, some logical thinking should be there. Otherwise you cannot correlate your productivity, your parameters with the productivity of your neighboring factory. Don't correlate that one. So logical correlation should be there, some logical input should be there for correlation. Okay, so this is all for today. If you have any question, you can ask me on today's session. And as told you, tomorrow we will start at 6:15 and close by 7:50, 7:30, as I have to go outside. So if any questions, you can ask, I can clarify you. Now, if a tool is there and आप उसको use नहीं कर रहे हो, so what will happen? It will become rusty. Okay, you will not be able to utilize it efficiently, effectively. So the thing is, you need to use these tools regularly. Try to play with the data, do some analysis, whether it's your section or no, not your section, whether it is responsibility, your responsibility or not. If you want to excel in your career, you need to try these things out. And this is the extra mile you have to run to get the extra mileage. So practice it. The basic thing is practice it, play with the data. And if you encounter any problem during in any calculation or making the scatter plot, making the control chart, if you encounter any problem, we are always there. It is not only for this 4 days of training program. After 6 months also, 2 months also, if you come back to us and ask us, this is the data we are making the control chart, can you please check whether it is right or wrong? We are going to help you out in that also. So practice it, and whatever the questions you have, raise it. Okay. So with this, we are closing the today's session. If you have any questions, you can share over the WhatsApp, or you can share it with us tomorrow also during the session. Okay. So good night. See you people tomorrow at 6:15.